Welcome to Verkada and networking, a series of videos where I explain basic networking concepts for those of you who might be picking up a Verkada project and are interested to understand more about how this essential infrastructure is helping us today, not only connect to the security infrastructure, but most other things that we use at the moment for work and leisure purposes. You might already be exposed at your home with one such device, which is the wireless broadband router. And in itself, it has a lot of these functions that you'll expect even in a regular office, right? So it gives you Wi-Fi connectivity. You can connect a few wired devices as well. It will backhaul all that traffic to the internet and possibly offer security functions on top to keep you at bay from hackers. Now, an enterprise network will have the same capabilities, but because of the large number of devices and load, the network infrastructure will actually be composed of multiple layers, starting from access switches. So you'll see there they have loads of different ports. In my case, this is a very small switch, but in an enterprise environment, you'll see it more like a pizza box with like 24 or 48 ports, going then into either distribution switches if you have a large network, and then onwards into routers and firewalls that will allow you to connect not only to the internet but with all your other locations. In today's session, I wanted to talk about an essential protocol called DHCP, Dynamic Host Configuration Protocol, that allows all the Verkada devices to get an IP address once they are connected into your local infrastructure via a regular switch. And this contrasts with you statically assigning IP addresses, which, as you can imagine, can be very time consuming. In your local area network, you will have a server that can either be a dedicated box if you have a very big estate, or it can run as a process on any layer 3 device, such as a router or a firewall, that will automatically assign IPs from a set range to any devices that are asking for one. The end device will connect. It will then send a discovery message saying, hey, I'm here, can I have an IP address? And then any local DHCP servers will reply with their offers, sending information not just about the IP address, but also the subnet mask. So that defines the size of the network. Default gateway. This will be most likely the router that you would send all the traffic to for the internet, and one or multiple DNS servers that will allow the host to translate regular names such as command.verkada.com into IP addresses, because again, computers don't really work with words and phrases, they do so with ones and zeros. Once the end device has chosen an IP address, it will broadcast the request again, asking for that specific one. And the reason why it's doing that is because if there are multiple servers offering different IP addresses, all but the chosen one will know, hey, the device has chosen something, let me take this offered address and put it back into my available pool. And then the original server that has offered the address that got accepted will then send an acknowledgement message. So discover, offer, request, acknowledge, which can be shortened to DORA. For each IP address offered, there is a lease time, and the idea behind it is that if the device goes offline, then it doesn't need to signal to the server, hey, I'm disconnected, you can have your IP address back. The server would automatically know that because at a predefined time, it will ask the host if it still needs that particular address. And obviously, if there is no response, it will take that address and put it back into its availability pool. I did mention initially that the DHCP servers need to be local to the device, because remember, initially the device does not have the capability to talk outside its broadcast domain or the local segment. And if the server is not present, you might have, for example, a server outside in a different subnet, you'll have to do something called the DHCP relay, where one of the routers in the segment will see the DHCP discovery message and then will forward it to the appropriate server. And you might be wondering at this point, okay, what should I do if I actually want the devices to always have the same IP address? Well, first of all, you have to understand that from a Verkada point of view, it doesn't really matter if their IP addresses change. They automatically will reconnect to the cloud and establish the connection. And this might actually contrast with your on-premise CCTV cameras, which might actually need static IP addresses to connect to the NVR. Needless to say that if for a particular reason you want the cameras to always have the same IP address, you can go inside the DHCP server and configure a static binding between a certain IP and a MAC address. The MAC address is unique. Each device has one that comes from the factory. It will actually never change. So every time the device will connect back, the DHCP server will take its MAC address, will look inside the binding table, and it will assign the same IP address. But remember, again, this is not essential when it comes to Verkada devices. However, if you do actually find yourself in need to assign static IP addresses to these devices, for example, you might not have a DHCP server around, you can actually go inside the settings of each of the cameras, scroll down, find the camera IP setting, and move it from automatic to manual. And command will now ask you for the same parameters that we mentioned previously, including the IP address, the subnet mask, default gateway, and 2 DNS servers. Have in mind that the devices have to be connected to the cloud for you to be able to push this configuration. And that means that initially you have to pre-stage them in a local area network that has DHCP capabilities. You plug them in, you allow them to connect to the cloud, you push the settings, you unplug them, and then put them in the segment that does not have DHCP. And make sure that the configuration is correct. If you can imagine, if you type in the wrong numbers, the camera will connect, but will not have the right parameters to be able to communicate. Luckily, the Verkada engineers have coded a fallback. So if the camera cannot connect to the cloud, after a while, it will go back and retry using DHCP, going back to its original state.